believe that's the idea. Yeah, we'll be passing around the peanuts very soon after that. For those of you who don't know, the JPL peanuts are a tradition that gives us a little bit of extra luck on our critical events. So if anybody out there wants to join in on peanuts and give us some extra good luck peanut vibe, we'd love to have it.
Well, there's a story behind that way back when in the early days of JPL, there were several missions, and there were 6 Ranger missions to the moon that failed.
Yep.
But then with Ranger 7, somebody passed around peanuts.
Yeah, and it worked, and you don't mess with what works. So
Absolutely.
It's not a superstition, it's a tradition. We just give ourselves that little bit of extra luck.
All right. So if you have peanuts at home, please have some.
That's right.
All right.
That's right.
Thanks, Julie.
Thanks.
NASA has had 7 successful Mars landings, but the EDL team never, ever becomes overconfident. JPL Chief Engineer Rob Manning says things have to work just right during 6.5 critical minutes.
Although we've done it before, landing on Mars is hard, and this mission is no different. The process to get from the top of the atmosphere of Mars to the surface we call entry, descent, and landing, or EDL. It takes thousands of steps to go from the top of the atmosphere to the surface, and each one of them has to work perfectly to be a successful mission. The process starts well above the top of the atmosphere of Mars. The cruise stage faces the sun. It also has its radio antenna, which faces Earth. But now we don't need the cruise stage. Its job is done. The next step, just 7 minutes before arriving to the top of the Mars atmosphere, is to separate the cruise stage. Before you hit the top of the atmosphere, though, the space capsule has to orient itself so that the heat shield is precisely facing the atmosphere. Now the fun begins. The vehicle is moving at nearly 13,000 miles an hour, but it's hitting the top of the atmosphere at a very shallow angle, 12 degrees. Any steeper, the vehicle will hit the thicker part of the atmosphere and it will melt and burn up. Any shallower, the vehicle will bounce off the atmosphere of Mars. At the very top of the atmosphere, it's about 70 miles above the surface of Mars, and the air is starting to get thicker and thicker and thicker. As it does that, the temperature of the heat shield gets well over 1,000 degrees centigrade, enough to melt steel. Over the next 2 minutes, the vehicle decelerates at a backbreaking 12 Earth Gs, from 13,000 miles an hour to about 1,000 miles an hour. At about 10 miles above the surface of Mars, a supersonic parachute is launched out of the back of the vehicle. 15 seconds after the parachute inflates, it's time to get rid of the heat shield. 6 pyrotechnic devices fire simultaneously, allowing the heat shield to fall and tumble away from the vehicle, exposing the lander to the surface of Mars. 10 seconds after the heat shield is dropped, 3 pyrotechnically deployed legs are released and locked for landing. About a minute later, the landing radar is turned on, sending pulses toward the surface of Mars as the vehicle starts to try to measure how high it is above the surface and how fast it's going. At about a mile above the surface of Mars, the lander falls away from the back shell and lights its engines. And very quickly, the vehicle must rotate out of the way so that the parachute and the back shell doesn't come down to hit it. The last thing that has to happen is that on the moment of contact, the engines have to shut down immediately. If they don't, the vehicle will tip over. So if all the steps of entry, descent, and landing happen perfectly and we are safely on the surface of Mars, we'll be ready to do some exciting new science.
Later on in the program. Meantime, let me introduce you to someone who has been working on InSight for 7 years. He's the project manager, Tom Hoffman. 7 years, and today's the day.
That's right, 7 years, but we're just a little over 40 minutes now, and we're going to be on the surface. It's going to be awesome.
Really exciting stuff.
Worth it.
All right, so let's talk about InSight. It's using tried and true technologies based on Phoenix. This time, there's a bigger challenge with communication, correct? Normally we have an orbiter that can give us bent pipe communications, but it's different this time.
That's right. And most of the time when we've landed recently, we've had Mars Odyssey, which can do bent pipe communications, and so we get real-time data as we go through EDL, and we've come to expect that, and actually we really, really want that. In this case, our primary technology, primary orbiter is Mars Reconnaissance Orbiter, and so what that's going to be doing is actually will be listening to us on the UHF. If you go to the video, you can see this. MRO will be listening to us and be getting all the primary data, and it will send it back to us, unfortunately, only at 3 hours after we land.
So it doesn't give us the bent pipe live information.
It doesn't. And we have a couple of other sources that we're looking at. We have a Green Bank Observatory in West Virginia, Max Planck Observatory in Effelsberg, Germany, which will be giving us UHF, but those only give us a couple of different points in time. And so we did something kind of cool this time. We brought along a couple CubeSats called Marco, and so hopefully they're both working great today.
Oh, fantastic.
So we're hoping that they're going to continue to work all the way through EDL, and they will be giving us real-time feed. So we can show how that works on the next video here.
There they are.
So you can see here's InSight with its crude stage, getting close to Mars. But we have two stalkers following us. They've been following us since we launched. They launched on the same launch vehicle as us. And so you can see the green there is we're sending UHF signals to them, and then they turn that around and send a much stronger signal back to Earth. We can't communicate on UHF direct to Earth with a signal that tells what's going on in the spacecraft, but Marco can. If it works for us all the way down to the surface, we're going to have some great information coming from Marcos.
So Marco is basically trying to fill that gap that we would have had if we had live communication coming down to us.
Absolutely.
So if it does not work, does it affect InSight's mission at all?
No, not at all. We'll just be doing a little more nail biting, but right now it looks like it's gonna be working, but it doesn't impact InSight at all. And we have one final way that we're going to know that we've got successfully to the ground, which is the spacecraft will phone home.
Okay.
Once it gets down to the ground, it's have gone 7 months through cruise, 7.5 minutes of tear, and it's going to call back and say, hey, I'm on the surface, I'm feeling pretty good, everything looks good so far.
And also to prep the audience, they're not, even after landing, we're not out of the woods just yet, correct?
Not just yet. We have one more step that we have to do. We have to let the dust settle, quite literally. We're going to kick up a lot of dust when we land. We need to let that dust settle before we want to unfurl our solar rays. We're 100% solar powered, so it's very important that we get those out. Unfortunately, both MRO and Marco will be out of view by the time that we have those completely unfurled, and so we're going to have to wait 5.5 hours until Odyssey comes by and tells us that yes, indeed, our solar arrays are out. So we'll definitely have a celebration when we get successful landing, but we're going to have to temper that just a little bit and wait about 5.5 hours to know absolutely for sure we're in good shape.
So we have immediate knowledge if we have the Marcos. So just to run it through it once again, what's going to happen with EDL? We have the video, the show. How exactly is this all going to play out in 6.5 minutes? And we can roll the video.
Okay. Yeah, so you can see here we're attached to the cruise stage. We drop that off, say thank you for the ride to Mars. It burns up in the atmosphere. You can see it gets very hot on our heat shield. We're getting up in some places maybe 3,000 degrees Fahrenheit as we go through this. We're on the heat shield for about 4 minutes. That dissipates about 90% of the energy that we need to dissipate before we get to the surface. Then we pop our parachute. We're going about 850 miles an hour when we pop the parachute. We're on that for about 2 minutes. Then we'll drop off the heat shield. We'll start acquiring the ground with our radar, very much like an F-16 fighter jet radar. The legs will pop out. We'll start descending. We drop for just a second, which is very terrifying for me. Our descent thrusters, we have 12 of them. They're 68-pound thrusters. Start thrusting and dropping us to the ground, and slowly we drop down, going only 5 miles an hour. So in that 6.5 minutes of tear, which is a little less than the 7 minutes, so that's great for me, we go from 12,300 miles an hour at 75 miles above the surface of Mars. We get to the surface, we're at 5.5 miles an hour.
That's amazing. That is absolutely amazing. Well, before you go, Tom, there was a couple of pictures we wanted to show you. We have watch parties taking place all over the country, and let's see if we can put one of these watch parties up for you to see. This is from Ohio. This is a person who has a watch party. It looks like in a classroom.
That is so awesome.
Isn't that great that folks are watching with us?
Yeah, I know people all across the globe are watching this, and we really want to put on a good show for them today.
All right. Well, I'll let you back in the room.
All right, I got to get back in there.
I know you're excited. All right, take care. Thanks for joining us.
Thank you.
let's introduce you to the people who built InSight, Lockheed Martin Space outside of Denver. These are the folks who built Viking in 1976 and Mars Phoenix in 2008. The operations team is there, and Lockheed InSight EDL manager Tim Lin is standing by. Tim, what's going on in there?
Team's getting really excited. We're just about ready. We're, about a half an hour from entry and the start of entry, descent, and landing. So the team is really excited, focused, but also very excited about the upcoming successful entry, descent, and landing we're getting close to.
Well, we talked about the fact that InSight is based on tried and true technology. It's based on Phoenix, but you've had to make a couple of changes for InSight. What were they?
Yeah, we've so obviously, as you said, we leveraged Phoenix a lot. There was a lot of great things that we're able to take from the Phoenix mission, but InSight is a unique mission. It's landing towards the equator of Mars, and a number of things are different. Where we're landing, we're about 1.5 kilometers higher in altitude. In addition, and so what that's required us to do is actually come in a little bit more shallow. In addition, we're a little bit heavier than Phoenix was, so we've had to increase some of the strength of some of the lander itself. So the parachute, we have had to increase the strength. We actually deploy the parachute a little bit higher because of some of the differences in our entry timeline. And because of when we're landing towards the end of dust season. So we also have actually increased the thickness of the heat shield. So we're about 1/4 inch thicker on our heat shield to accommodate that potential sandblasting that we could see when we actually do our entry, descent, and landing. So a number of things we've changed, but we've obviously leveraged a lot from the very successful Phoenix mission as well.
That's fantastic. So you were able to kind of customize it, because there were some concerns earlier on that there was a dust storm taking place. It was dust storm season.
That's right. In fact, we've had a lot of great support from our orbiting assets, MRO and Odyssey, a couple of spacecraft that we've partnered with JPL and that were built here at Lockheed Martin. They've actually provided a lot of great insight into the weather on Mars, any dust storms that are potentially happening on Mars. And as of today, and actually the last couple of weeks, it's been great on the surface of Mars. We're anticipating a very nominal, very seasonal weather in terms of both density, atmosphere, as well as temperature, and dust storms appear to be very benign, so we're very optimistic it's going to be a great day for landing on the surface of Mars.
All right. That's great news. Thanks, Tim, and I know your team is getting excited over there just as much as we are. Take care.
Absolutely. Yeah, thanks a lot. Okay.
The time now is 11:21. It's about 20 minutes. The tension is building in both control rooms. It's about 20 minutes before cruise stage separation. It's not too far off. Cruise stage separation is expected at about 40 minutes past the hour, so we are indeed getting close. So where is InSight going to Mars? It's a place called Elysium Planitia. Planitia is Latin for flat. Elysium is ancient Greek for afterlife paradise. It's located near the equator, north of Gale Crater, not too far from Curiosity rover. The team calls it the biggest parking lot on Mars. It's a place that's safe, got plenty of sunshine, that will power solar instruments to study the interior of Mars.
What's inside Mars? We know a lot about what's inside Earth. But at Mars, we've only just scratched the surface. To learn how Mars formed, we have to study its deep interior. NASA's InSight lander was designed to do just that by taking the planet's vital signs, listening for its pulse or seismic activity, including any Marsquakes, taking its temperature to see how much heat is flowing out from deep inside, and checking its reflexes to see how much the planet wobbles as it whips around the sun. These all provide clues to what the planet is really like inside. So what's inside Mars? InSight can help us find out by giving Mars its first thorough checkup since it formed 4.5 billion years ago. The more we learn, the better we'll understand all the rocky planets and the history of our solar system.
Joining us now is Bruce Bennard, the principal investigator of Mars InSight. InSight is a mission to Mars, but we keep hearing again and again it's more than a mission to Mars.
That's right, Gay. I mean, we're going to Mars, obviously, to study the Martian interior and to map out the divisions inside Mars, but we want to use that information to understand more about the solar system as a whole and how rocky planets form.
And rocky planets, we have an image to show folks. So we're talking about Earth, the Moon, Mars.
Mercury, Venus, yes, the planets of the inner solar system that are made mostly of rocks. And they all share the same basic structure with a dense iron core, a rocky mantle, and then a crust of lighter silicate rocks. But the very details of the thicknesses of those layers, the sizes, and the compositions give us a lot of clues as to how those planets form and why they went down very different paths into the different planets we see today.
So explain to me, we are going to have a lander, you're going to be on the surface. How will you be able to study the interior?
Well, we use what are called geophysical instruments. They use the principles of physics to actually see through the rocks. I mean, we're using seismic waves. It's the same way you might use a flash bulb to take pictures of something. We're using Mars quakes, which send out vibrational waves through the planet, and as they go through the planet, they reflect off boundaries, they get bent, they change their velocity, and it changes the wiggles that you see on a seismogram. When we go through the planet, so you can see that here it hits the various boundaries, and those waves are reflected, sometimes they're bent. It becomes a pretty complicated pattern, but scientifically we've learned over the last 100 years how to interpret the code of the signal as it comes back up to the surface, and the seismometers pick up that signal and then turn it into data that we can use on Earth to understand, what the 3D structure is of the planet.
So normally you use 3 seismometers. In this case, you're bringing SEIS. That's 1. How are you going to be able to get that information using 1?
Well, we had to get kind of clever because on the Earth, usually you have plenty of seismometers. You can use multiple seismometers to triangulate in on where the earthquake is. On Mars, we're going to do something a little bit different. We're going to use not only the P and the S waves that you may have heard about, but we're using the surface waves. And here you can see the surface waves kind of moving out from Marsquake, and as it passes over the InSight lander, you can see the seismogram up there in the upper left-hand corner where you have the wiggles. Now, those waves keep on going around the planet, and because Mars is not so large, they still have a fair amount of amplitude. They haven't gotten completely damped out by the time it's gone all the way around the planet, passes over the spacecraft again, and finally, even the wave that went the other way around the planet comes across and hits us yet a third time. And so we have extra information over just the P and the S wave. We have these surface wave arrivals that we can use to pinpoint the distance from the Marsquake to our lander, and then we use something called polarization analysis to figure out which direction the waves are coming from. And by doing that, we can do the same thing that we can do with 3 stations on the Earth, just using the P and the S waves.
And very quickly, there is still another instrument built by DLR that's also being carried up by InSight. Can you talk a little bit about that?
Yeah, that's our heat flow probe, and it's a pretty cool instrument that uses a mechanical mole, we call it, to burrow its way down into the surface. It has a motor that winds up a hammer, and it knocks itself down just a few millimeters at a time. But we do that 20 or 30,000 hammer strokes, and it gets us down. We hope to get down to be about 16 feet below the surface. And once we get down there, we're actually measuring the heat coming out of the planet by measuring the temperature along the cable as it comes up to the surface, and looking at how that temperature increases as we go down, and extrapolate that deep into the planet to understand how much energy there is inside the planet to drive the geology and to drive volcanism, Marsquakes, all kinds of activity.
It's amazing how much you'll be able to learn from the surface about the interior.
That's right. I think it is amazing, and it's been something that I've been working on for my whole professional career, and it's just I find it fascinating. But
all right, we'll talk about that. Thanks,
okay.
Bruce. Bruce first thought of a mission like this, as he mentions, 40 years ago when he was a graduate student. The rest of the team hasn't waited quite that long, but this is a big moment for them, too. Recently, we sat down with a few of the members and asked them what is it going to be like as we get close to landing.
It's a very difficult thing to do, and everything has to go perfectly. As humans, we've sent 17 different missions to the surface of Mars, and 10 of them have crashed. Before we can land on Mars, we have to get to Mars. How do we get to Mars?
The main responsibility of the navigation team is to ensure that the spacecraft is delivered to the right point at the top of the Martian atmosphere. The target location is about 12 kilometers in size. Our accuracy is comparable to shooting a basketball from Staples Center in downtown LA and hitting nothing but net in a basketball hoop in New York City that is moving at a speed of about 2 feet per second and is spinning about its axis.
The landing site, we have an ellipse that's pretty big. It's about 60 miles long. We could land anywhere in that ellipse. There's a chance that we could land right on a rock, and we don't really have any control over that, so that's what makes me nervous.
We've tested the radar by flying it on a helicopter. We've tested pieces of the heat shield by putting them in an arc jet facility. We've tested the parachute by testing it in a wind tunnel. And putting all that together in a very tightly controlled sequence where every single thing has to go right, we've never tested that. And the first time it's going to happen is once you deliver us to Mars.
It is about 11:29 a.m. Pacific, and you're watching live coverage of the InSight landing from NASA's Jet Propulsion Laboratory in Pasadena, California. We are about a half hour away from landing, and people all over the world are watching. Take a look at a map that we have for you. We can show you right now. This is a watch in person map where people have watch parties all over the world, all over the United States, in Paris, in Berlin, even off the coast of Madagascar. And folks in the Big Apple will also be watching today. The NASDAQ Tower will switch over to landing coverage for about an hour. That means people in Times Square can watch too. And later today, NASA will have the honor of ringing the closing bell, and that will be a little over an hour from now. And if you are watching, take a picture and send it to us using hashtag Mars Landing. Here is one. I believe it is from the California Science Center in Los Angeles, and I am told Mayor Eric Garcetti will be visiting later today. Things are getting more active for the team now. Let's check back in with Julie Wirtz-Chen in the control room. What's going on, Julie?
So we've heard from MRO a couple of times. That's Mars Reconnaissance Orbiter. They are doing their slew. They're ready to support us. They're doing great. And we heard from both Marcos, Marco A and B, that they're out there. We've got telemetry lock with them from the ground stations here, so they're doing great. And everybody's ready to go. So we're pretty excited.
Fantastic. We will check back in with Julie in a moment. Meantime, this is a good time to tell you a little bit more about that technology experiment we've been talking about, Marco. As we mentioned earlier, InSight does not have an orbiter in position to send EDL data back live. So the CubeSats hope to fill that gap. Here's how they'll work.
Communicating between Mars and Earth requires a complicated choreography, with everything in the right place at the right time. Sometimes hours can pass before information is relayed from one planet to the other. That's why when NASA's Mars InSight lander launches this year, the rocket will carry 2 tiny satellites on a technology test of their own. Meet Mars Cube 1. Marco, NASA's first CubeSat mission to deep space. These briefcase-sized satellites will travel separately from the InSight lander while they test out new miniaturized technologies. And if they make it to Mars, they could relay information back to Earth about InSight's descent and touchdown, and do it in mere minutes. Although this fast communication isn't crucial to the success of the InSight lander, this CubeSat test could change the way future spacecraft phone home.
All right. right, let's check back with Julie to see if the Marcos are indeed ready to support and listen for InSight. Julie, what do you know?
So they are ready to go. I haven't heard about their slew coming up yet, but they are ready to go. We've heard from them. They're both healthy and they're both doing great, which is just wonderful news. So I think they should be doing a slew in just a minute. Actually, yeah, I think they should be doing a slew in just a minute.
We'll stand by and listen then.
Oh, they're separated? No. You got me going. It's funny.
This systems, we can confirm we are entry minus 20 minutes. EDL nav 2 has been initiated. The star tracker has been powered off.
That the nav2 software has been initiated. So when we're in cruise, we use a star tracker in a similar manner to how sailors navigated years ago. We look at the stars and get our relative position from them. And we use a star tracker for that. And now that we're close enough to Mars, we don't need that anymore. So we're going to transition to what's called nav2 software. And that lets us basically just use velocity and acceleration from this point on. So we don't need the star tracker anymore.
Salute to EDL bent pipe mode.
Marco, clarify, slew to inertial or started bent pipe?
Slew to appropriate attitude for bent pipe. Bent pipe mode will be entered shortly.
Okay, thank you very much.
And that was obviously our confirmation of the slew for Marco, so that's great news.
Fantastic.
So I was saying before that the nav2 software will propagate from here on out, and we'll use velocity and acceleration. So we have powered off our star tracker, and we're on our nav2 software, and everything's looking great.
Okay. Thanks, Julie.
Thanks.
All right, the cruise stage separation is just about 4 minutes away, and Rob Manning joins us now. Rob is the chief engineer here at JPL and an absolute veteran of Mars landings. We're going to play a little video for you right now. You haven't seen it yet, but we'll roll it. Let's go ahead. This is
Lander show live. 14 reports carrier log.
That day, Rob. There you are. You were the phase lead. You were sitting up front.
Yeah. That's what I look like when it's successful.
Yes.
I hate to see what it would be like if I wasn't successful.
But talk about that. What is EDL like? Why is it so hard?
Well, it's many years of work by many, many people who struggle to put all the pieces together, and particularly because we can't really test entry, descent, and landing on this planet. It's much more complicated. Mars has a lower atmosphere, thinner atmosphere, less gravity. You just can't put the pieces. So imagine you had a big Broadway production, but you couldn't really do the show until all the audience shows up. So that's what it feels like. So you never really know if you've really done it right.
Well, we've done it 7 times. Can we say that, hey, piece of cake, we know what we're doing?
No, I don't think so. I mean, we get better at it, and there's no doubt. We've learned for both the successes and our own failures, including failures of other missions outside of this country. So those pieces come together in our mind's eye. We try to put what we learn together and just do the best we can. And if we don't succeed, we will learn, because we are collecting data on the way down. If something bad happens today, we'll be able to take what we learned, even though we may fall on the ground after getting kicked off the horse. We'll get back up, brush ourselves off, figure out what we did wrong, and get back on the horse.
Well, there's a lot of uncertainty. Just very quickly, give us some possible scenarios of what could happen during EDL today, especially during communications.
Well, the great news about having communications, there's almost anything that can go wrong. There's a very good chance we'll figure it out. But things like, the parachute has to go right. We know you don't open parachutes on Earth going Mach 1.5 times the speed of sound. You just don't do that. You don't need to on this planet. But we have to, because if we waited any longer, we'd be on the ground. A very complicated radar system has to work from outer space all the way to the ground and look for the ground. What if it locked up on the heat shield? Well, we've tried to avoid that problem. We fixed that problem, we think, to prevent that from happening. But what if we got it wrong? Things like that could happen, and our vehicle could have things bad happen. But we've worked hard to prevent them.
So
at this time, we expect
we're getting close. We're going to go to the control room for cruise stage separation, Rob.
Okay.
Thank you, MRO.
I need to take off common. Yeah, yes.
InSight Systems, EDL
Go ahead.
on InSight Court. At this time, MRO will have loaded their electrosequences. Marco is expecting carrier lock at any time. Marco B is reported there in bent pipe. Still waiting on A.
Copy that. Thank you.
Radio Science report, UHF carrier detected.
EDLCom, Marco Alpha is in bent pipe mode. Marco Bravo has locked on the carrier. Marco Alpha has also locked on carrier.
Systems Ace on InSight Cord. As expected, the DSN has LOS for InSight Expand.
Copy that. Thank you. All station InSight Systems on InSight Cord. DSN has lost the X-band signal from InSight, indicated expected cruise stage separation. Standing by for UHF signal acquisition via Marco or Radio Science.
We are about 5 minutes from entry and have confirmation we've lost the X-band signal from InSight. This was expected because we have transitioned from the antenna on the cruise stage to the UHF antenna on board the spacecraft. Ground stations have detected the UHF signal, and Marco has locked on the signal. This confirms that InSight is transmitting UHF signals as expected. InSight telemetry through the Marco relay is not expected until about 2 minutes before entry.
So, Rob, that was exactly what we were hoping to hear, that the Marcos are
The vehicle
working.
has also performed the turn to entry maneuver. The vehicle is turning away from a sun-pointing attitude and oriented itself to enter the Martian atmosphere.
This is a big first step. Getting the cruise stage separated. It's now, after the vehicle turns itself to the right orientation, the cruise stage is now going to be get further and further away until it's about 3 or 4 football fields away, and will burn up in parallel as the vehicle enters Mars.
And Christine mentioned turn to entry. What does that mean?
Well, it's because the cruise stage has to be pushed off to one side, like this. The rest of the vehicle has to turn to face the atmosphere and to be dead nuts on as it hits the top of the atmosphere.
So this is taking all the heat coming into the atmosphere.
Exactly. It'll be both provide a source of drag, but also thermal protection, because it gets over 1,500 degrees Celsius on the top of on this heat shield. Very, very hot. But on the inside of the heat shield, it's maybe only a fraction of a few degrees above room temperature. So it's a wonderful protective device to keep our lander safe.
All right. So the next thing we're standing by for is
entry. Getting to the top of the atmosphere, gradually slowing down. Right now, the vehicle's just now beginning to, very soon, we'll be beginning to feel the atmosphere touching it. Actually, entry is above the atmosphere slightly, so it's really not until half a minute or so after entry before we start really detecting the fact that that atmosphere is slowing us down.
All right, we'll be standing by.
Yes, exciting.
Rob, now entry is scheduled for 11:47. The cruise stage SEP and the entry times are locked in, correct?
They are. They're locked in when we selected the target and aimed the vehicle very precisely. That allows us to know exactly when we hit the entry point, which is 55 kilometers from the center of Mars.
So we know those times are locked in, but what about all the other events that take place in EVA?
Reggie Science reports dropping carrier power as expected.
Marco A and Marco B have telemetry.
Just heard, both Marcos have telemetry.
They are doing their job. These small CubeSats are relaying ones and zeros with a few seconds lag from the vehicle up to these two vehicles, and they forward them back to Earth to the Deep Space Network using X-band antennas.
And keep in mind, this was all an experiment. We weren't sure that this was going to work, but we had this need that we didn't have live communication in this particular mission.
Well, we don't really need communications. We don't need their information, except if something went wrong. We would very much like to get the data right now. We have other spacecraft.
We are now receiving InSight telemetry via the Marco relay.
It's flowing into the station. That means the team now can watch the data flowing onto their screens as if they're communicating directly.
This data will provide detailed information about the state of the spacecraft throughout EDL.
We were on pins and needles waiting for that because we weren't really sure.
This is wonderful news. This will allow us to give some, if this continues working all the way to the ground and beyond, we might even see a first picture from the surface of Mars.
Wouldn't that be great?
Very soon.
Atmospheric entry on my mark. 3, 2, 1, mark.
Here we go.
So in a few seconds, the vehicle will start sensing the atmosphere. I said 22 kilometers from the center of Mars, and it's going to start to slow down very, very slowly at first, but then faster and faster and faster till to reaches about 7 Gs. I made that mistake on the video. It's actually 7 Gs, not 12. And so but we'll still very, very quickly slow down, and from 15.
In approximately 1 minute, InSight is expected to reach its maximum heating rate.
Oh, yes.
Plasma blackout is possible during peak heating and could cause a temporary dropout of telemetry. This could last for as long as 2 minutes.
Yeah, the gas that comes off the heat shield as it's slowing down, it looks like a meteor if you're on Mars watching the streak go by. That brightness of gas does interfere with the radio reception. And so it's possible that Marco will lose that signal while it's going through this very hot entry.
But not to be alarmed.
Not to be alarmed. It's part of the design. We completely expect it.
Radio science reports plasma blackout as expected.
Okay. Oh, wow.
Ground stations have reported plasma blackout, still receiving InSight telemetry via Marco.
Marco Alpha has carrier interruption.
InSight should now be experiencing the peak heating rate. Portions of the heat shield may reach nearly 3,000 degrees Fahrenheit as it protects the lander from the heating environment.
That's hot.
Marco Bravo shows carrier interruption, but still in lock.
InSight has passed through peak deceleration. Telemetry shows the spacecraft saw about 8 Gs.
Marco Alpha and Marco Bravo maintain lock.
Radio science reports carrier detected.
Yeah.
So, several different communications coming in.
InSight is now traveling at a velocity of 2,000 meters per second.
Seems to have passed this very critical point of peak heating and peak deceleration. The next big step is parachute inflation.
And you can see that on our timeline on the bottom of the screen. The next event is parachute deploy.
InSight is now traveling at 1,000 meters per second.
Very close.
Once InSight slows to about 400 meters per second, it will deploy its 12-meter diameter supersonic parachute. The parachute will deploy nominally at about Mach 1.7. Standing by for parachute deploy.
Radio science reports a sudden change in Doppler.
Ground stations are observing signals consistent with parachute deploy.
Marco Alpha, Marco Bravo maintain lock status.
Telemetry shows parachute deployment. Radar powered on. Heat shield separation commanded.
This is really good news so far.
That's fantastic.
I'm on pins and needles.
Yes. We have radar activation where the radar is beginning to search for the ground. Once the radar locks on the ground and InSight is about 1 kilometer above the surface, the lander will separate from the back shell and begin terminal descent using its 12 descent engines. Altitude convergence, the radar has locked on the ground.
Yes.
Standing by for lander separation.
Carrier interruption on Marco Alpha and Marco Bravo.
Lander separation commanded.
Yes.
Altitude 600 meters. Gravity turn, altitude 400 meters.
We're getting there.
300 meters. 200 meters. 80 meters. 60 meters. 50 meters, constant velocity. 37 meters. 30 meters. 20 meters. 17 meters, standing by for touchdown. Touchdown confirmed.
This never gets old.
No, it doesn't, Rob. Control room just erupted.
Fabulous.
Shaking hands with the Marco team there.
Christine, you did great. Jim Bridenstine, one of the key designers at Lockheed. Sandy Krasner, what a great team. This is really fabulous.
Fantastic news.
Thank you.
Lots of fist bumping going on in there. What a relief. We've cut over to the camera over in Times Square. Boy, people are weathering the rain to see this.
They can't help it. This is the hardest part. Getting to the surface of Mars is very hard. This thing has a lot more to do, though. There's a lot more to go on both today and the days that follow before the science can begin. But just getting a vehicle from Earth to the surface of Mars is no mean feat.
And Rob, could you talk about that? I mean, just the mere accomplishment here that we're seeing.
You have to understand that this vehicle is very complicated. It uses 12 engines. Each of those engines are pulsed 10 times a second, producing these little tiny impulses, almost like little bullets that keep the vehicle going at a constant velocity as it approaches the ground, and still going over 5 miles an hour. So those legs feel a fair amount of crush. We still don't know the state of the vehicle right now. We need to look to make sure there are no rocks nearby. The solar panels will be in just